Hello everyone, welcome to Fahad's tutorial once again, and this is Fahad Hossain. So in this video I'm going to explain something very important in chemistry, which is electron configurations. In my previous classes I chronologically explained what are the electrons, protons and neutrons in atom and the arrangements of electrons into an atom. So in this video I am going to explain how we will do these electron configurations based on the periodic table. So I hope that you already studied these things earlier, and of course you have good idea on periodic table. So if you see this periodic table, we know that there are 118 elements, and of course each and every single elements here they have specific proton numbers, and then based on these proton numbers they are placed into a specific positions of periodic table. So this is group 1, this is group 2, and then like this it's going to here and until a group number 18, which is actually the inert gases. So in this periodic table we know that there are like more than like 118 elements, and each and every element is placed in a specific space of periodic table. Because of each and every elements they have specific proton numbers, and these proton numbers, it means that that number of protons are placed in the atom of that elements, and that's why it placed in a specific space of periodic table. So understanding of electron configurations, if you see this one, earlier in my classes I explained this, the s-p-d-f orbital, and you know that according to Bohr's model we know that electrons is revolving around the nucleus in a circular paths, and these are known K shell, L shell, M shell, N shell and O shell. And then according to the 2n square theory we know that how many electrons can be in that shells. So from that levels we know also that there are some sub-energy levels of each and orbit. So like 1s, 2s, 2p, 3s, 3p, 3d. So based on that we know that in case of s orbital there can be 2 electrons. In case of p orbital there can be 6 electrons. In case of d, 10 electrons. In case of f, 14 electrons. So these amounts of electrons can be the maximum in case of this orbital. So if we see the chronology of these electron configurations, then we can start from here, that it would be 1s2, 2s2, 2p6. As you know that s2, p6, d10 and f14. So based on that we are going maintaining these things. So here 2s, 2p, and then 3s2, 3p6, 4s2, and then 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 4f14, 5d10, 6p6, 7s2, 5f14, 6d10, 7p6, and last of all 8s2. So following this flowing, that we know that how we need to understand that how we will do this electron configuration based on the proton numbers of different elements. Like if I say that this is neon, okay, so this is neon 10, and you know that there are 10 protons in neon elements and neon atoms inside. So if we go for the electron configurations of neon, we can have 1s2, 2s2, 2p6, because there are 10 electrons. So if we add the electrons upon the orbitals, we will have 2 plus 2 plus 6 is equal to 10. So according to this chronology we can find the electron configuration based on the proton numbers. So if you go for calcium, you see calcium 20, then what we'll have? we'll have 1s2, 2s2, 2p6, 3s2, 3p6, and then 4s2. It means that if we count the electrons of the orbitals, we will have 20. So 2 plus 2 plus 6 plus 2 plus 6 and 2, it's altogether 20. So we can have the configurations of calcium. And now if we see some sort of exceptions, like in case of chromium and copper, there are something that we need to consider. In this case, there are some exceptions. Why? Because there is an interesting thing inside. What are these? Like this is 24. So if we go 1s2, 2s2, 2p6, 3s2, 3p6, 4s and 3d. And most importantly, there are another thing that we need to consider. Why after 3p, 4s arrive and then 3d? Why electrons goes first in 4s orbital rather going 3d orbital? Because and especially it requires some more explanation, because to understand the energy levels, electrons feel at first the lower energy level, and then after feeling lower energy level, it goes to the higher energy levels. Because how to calculate how to understand that what are the energy levels? Like in case of 3D, you must know that I'll explain it in the later class, that the principal quantum number and the additional quantum number will be joined together. And in 3D, the principal quantum number is 3, and in case of D, the additional quantum number is 2, so it's together 5. I'll explain later on, but in case of 4s, the principal quantum number of 4s is 4, but in case of s, it's 0, so here is 4. So we can say that the energy of 4s orbital is less than 3d orbital. That is why electron goes to 4s orbital first and then 3d orbital. So that is why here, what's going on? Like, okay, before going to explain this, I need to explain one more thing, which is scandium. Okay, scandium 21. So if you see the periodic table, you have an idea that scandium is placed after calcium. So 21 is the number of protons of scandium atoms. So if we go to the electron configurations chronologically, we will have 1s2, 2s2, 2p6, 3s2, 3p6, 4s and 3d. Here what's going on, that 2 plus 2 plus 6 plus 2 plus 6 is 18. But to get 21, we need to add 3 more electrons. So here if you see that this is 4s2 and 3d1, this is the exact electron configurations of scandium. But we know that electron will go to 4s orbital first, and we of course know that when we will write this electron configuration, we will do this accordingly. So what is the accordingly things? Like we need to place 3d here and then 4s. So here will be 3d1 and 4s2. It means we need to write this way, and we can find the energy levels. Like here 1s2, this is K shell, 2s2, 2p6, this is L shell, and you can see in K shell there are 2 electrons. In L shell there are 8 electrons, 2 plus 6, and in M shell there are 9 electrons. This is very important, 9 electrons. How? 2 plus 6 plus 1. And in case of KLMN shell, that means in the 4th shell there are 2 electrons. So in case of scandium, we see that electron configured like this. We know that there should be, in d orbital it can be 10 electrons, but we cannot put here 3d2 and 4s1, no. So 4s orbital are the lower energy level than 3d. So electron will fill 4s orbital first and then 3d orbital. But we need to write this in this way, so that we can understand that in M orbital, there are in M shell actually there are 9 electrons, and in N shell there are 2 electrons. So in case of chromium, what's going on here? We can see that here we can see that 1s2, 2s2, 2p6, 3s2, 3p6, 4s and 3d. So according to this law, 4s orbital should fill first, and then if it is 2, then you see there are some differences, like 2 plus 2 plus 6 plus 2, 6 and 2 is altogether 20. So there are only 4 electrons left to be in the 3d orbital, but it's not right, and that's in these electron configurations it's not stable. Why? Because d orbital are not getting the half fill of its own electron configurations. So what we need to do, we need to put 5 instead of 4. So here would be 5 and here would be 1, and this electron configuration is more stable than the previous one. So we need to put 3d5 and 4s1 in case of chromium, and that is some exceptions which is already mentioned in your book. So you must remember that 4s2 would be the first priority, but when 3d would be 4, after 4s2 it's not the stable electron configurations. It should be 3d5 and 4. So if you add all the number of electrons, you will have the electron configuration of chromium. But we won't write this way, we will write this way. So after 3p6 there would be 3d5 and 4s1. So we know that in K shell there are 2 electrons, in L shell there are 8 electrons, and in M shell there are 13 electrons, and in N shell there are 1 electrons in case of chromium. So in case of chromium electron configurations, we can say that chromium is 2, 8, 13, 1. So it altogether 24. So how these 24 electrons is arranged in chromium atom, this is the arrangements. And that is why electron configuration is the basic study of chemistry. So those who are studying right now in English versions and even O levels, you please give the emphasizement over here to understand the electron configurations correctly. And most importantly, the next class will be following that how we can understand that in which row and column the elements are supposed to be based on the electron configurations. We also can find out the positions of an elements in periodic table from their electron configurations, and that is also very important and very basic of chemistry. So I hope you understand this one. Okay, so we know that electron will go first to 4s, so it will be 4s2 first. But if 4s2, if we see that 3d would be 4 or 9, we won't provide like 4s2 and 3d4, no. So what would be in case of copper? In case of copper, it would be 1s2, 2s2, 2p6, 3s2, 3p6. So we will write 3d and 4s. So it means that 2 plus 2 plus 6 plus 2 plus 6 is 18. So here are 29. So more 11 electrons. So if we put here 2, then we need to put 9 here. But that is again wrong, because in this electron configurations again it will lose its stability. So for the stability, what will it do? And what is the electron configurations would be here? 3d would be 10 and 4s would be 1. That is very, very important. So 3d would be 10 in case of copper and 3d would be 5 in case of chromium, when both cases 4s would be 1. And in this case we can say that in like previous one, K shell 2 electrons, L shell 8 electrons, N shells Here 18 electrons, as you know that based on the 12 square formula, K shell can have 2 electrons, L shell can have 8 electrons, M shell can have 18 electrons, and here we got the 18 electrons, and here are only 1 electrons in N shell in case of copper. So that is why electron configuration is very important. Okay, so I hope in your question paper there is a question which is very common, that some exceptions like this one, copper and chromium. Please do it in your own in case of copper and chromium. So if I give you some more idea, like this one, there are something that I need to explain it more, that some students can have a question like why in this 3D orbital the additional quantum number is 2, and why this is 3, and what are these quantum numbers. I'll explain it more, but in this, not in this level, in the next level, then I'll explain why 3D and 4S are coming, to understand the energy levels. So we know this one, we also know this one, that this copper and chromium, the electron configurations are like that. So if we go for some bigger elements, like you see there are ferrum, which is 26 electrons, even copper 29 that we did earlier. So if we go silver 47 and cadmium 48, or even we can do like iodine 53, fine, okay, let's do silver 47. Okay, then what will be the electron configuration? So we need to go till 47. So if I say 1s2, 2s2, 2p6, 3s2, 3p6, okay, we need to write here 3d10, because we know that an electron will go first to 4s2, but here it will be 3d10, 4s2, and then after 4s2, 4p6, 5s2, 4d10, 5p, okay, let's see, okay, 4, 10, 12, 18, 28, 30, 36, 38, 48. So here there is again one thing, that is 48. So we can say that it will be 49, and so 2 to 4, 6, 10, 12, 18, 28, 30, 36, 38, and this is 47. So we see that electron goes to this way, like 49 and 5s2. So again, what we need to do? We need to say that this one would be 5s1 and 4d10. So the electron configuration would be again that 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, and 5s1. So it means we can see that from the electron configurations of silver, in K shell there are 2 electrons, in L shell there are 8 electrons, in M shell there are 18 electrons, N shell there are also 18 electrons. So K, L, M, N and O shell, that means in the 5th number shell there are only 1 electron. That is very important. So when we do these electron configurations, we need to remember one thing, that we need to go through this way. Of course, based on the energy level, electron will go to the lower energy level first and then higher energy level. But when we will write the electron configurations, we need to write this way, so that you can understand which levels how many electrons are. So like here we see that 4s, 4p, 4d, and of course there are 4f orbital, but there is not enough electrons to go there, because the energy of the proton numbers of silver is 47. So according to the proton numbers, we need to configure electrons following these consequences. So this is very important. And one last thing that I need to mention here, if I erase this, please think that one important thing, that in case of 4D 5S, in case of 3D 4S, what's going on? In case of 3D and 4S, in case of 4D and 5S, what's going on? It means that when we have two electrons need to be 4s2 first, here 9 can't be. So here would be 10 and 1. Here would be 10 and 1. So if you see in this electron configuration or all these electron configurations, if I express these s orbitals quantum number by n, then it would be n minus 1. So n is 1. So if 5 is n, then 4 would be n minus 1 d5, or n is 1, n minus 1 d10 is the stable electron configuration. So there are some MCQ in your question paper like this, that which one is the stable electron configurations. N means normal number. So if it is 4 S1, it would be 3 D5. It would be, if N is 5 S1, then it would be 4 D10. So in case of s orbital or d orbital, when these two will be, besides that 4s should be 1 if there is 5 electrons and 10 electrons. In this case, we can say that this d orbital is half filled and this d orbital is full filled, because we know that in d orbital there can be 5 or 10 electrons. I mean 5 in case of half fill and 10 is full fill. So when we see that n S1, that means anything, like if it is 6 S1, it will be 5 D10. If it is 5 S1, it will be 4 D10. In case of 4 S1, it will be 3 D10, because 2D is not possible. So 3D, 4D, 5D, these are the orbitals. So I hope you understand this one. I explained a very primary level for you and those who you are studying in SSC level and O level. Please concentrate these electron configurations and practice in your sheet, and like till 50 or even 60, or even if you want you can complete 118 electron configurations as your own. So I think practice makes everybody perfect. So if you have time to think, and if you just dedicate to your study in case of chemistry, please do it in your own hand and these configurations. And please do let me know in the comment sections of these videos that how much is improving in your study and what is your requirements. And please let me know your feedback so that I can adjust it on my next class. So take care, stay well and stay blessed. Bye.